Hello everybody. Previously I made a list of videos that talk about various techniques of segmentation, but segmentation is in fact just one step, okay, in computer vision, and it's not the goal. There are many things that we can do with the segments we would have detected or extracted. Now, one thing that we can do with these segments is to do the recognition, that is, try to understand what these segments are. So try to recognize these segments, okay? But before doing the recognition, we need something that is called the descriptor or descriptors. So the descriptor is just a set of numbers that are associated with the segments, okay, and they are used for the recognition task. Now, these descriptors are also known as a feature vector, and of course they are, as the name suggests, feature vector, are in the form of a vector. Okay, so now a descriptor or a feature vector is just a vector that contains numbers. Okay, and I'm going to give you an example right away. So for example, RGB, this is a feature vector and can be used to represent segments. In fact, there are some techniques that do the recognition or perform the recognition based on the RGB information. Okay, but the problem is that we can't always use the raw pixel intensities, which is in this case RGB values. The reason is because such descriptor or such feature vector is not robust. Now, what do we mean with robust? What is the meaning of robust? So a robust feature vector or a robust descriptor must be invariant to a set of say variables. So a feature vector must be invariant first to rotation, scale, must be invariant also against position and illumination. So of course maybe there are other variables, but basically when we have a feature vector that is robust against or invariant against these changes, then we say that our feature vector is robust. Now, just to be precise, what do I mean with invariant against rotation? This means that even if the segment is rotated, the feature vector is the same. The same thing is true for scale. When the scale is changed, okay, the feature vector should stay also the same. Now, let's try this, for example, on the RGB. Let's say that I have an image that contains an object in this form, okay, and the image of the same object but with a different scale. So in that case, the feature vector RGB would be completely different, okay, because in this square here, the number of features of the RGB would be much higher than the number of elements in the feature vector of this smaller square. Okay, because of that, we say that such feature vector is has changed with respect to scale. Okay, in other words, it's not invariant against scale. So what I'm going to discuss in the next videos, I have the intention to explain several techniques that talk about how we can extract these feature vectors, and also discuss their sometimes pros and cons, which manifest in terms of these variables. There is just another thing that I want to say, which is just a terminology, something about terminology. Usually when we have a feature vector, this is called a descriptor or description, okay? But of course sometimes before we get before computing this feature vector or this descriptor, we have to do some pre-processings, okay? And when we are in the phase of the pre-processing, then we are talking about the representation, okay, the representation of this segment. So the representation includes all the pre-processing steps before getting the final feature vector or the final descriptor. Okay, so with that said, the first technique or the feature vector that I'm going to discuss is called the chain code, which would be the subject of the next video.